again is equal to shear yx, and this is equal to VQ over IT. Okay, so again, the definition for the V, Q, and I are the same, but I want you all to specifically remember this. Okay, regardless of the location that you are going to calculate. I repeat again, regardless of the location of the stresses that you can calculate, V and I are constant. Okay, Q and T are your variables. Okay, variable is dependent on the position of interest. Okay, dependent on the position of interest, and T is the thickness okay, of the section. And is in meters. Okay, so now we are going to look at the theory. Okay, we're going to derive the theory. Okay, and how we derive the theory will set the rules that we have to apply. I repeat again, how we derive the theory will set the rules on how we're going to apply this formula. Okay, as I say, there's only two or three formulas. Okay, the first one is the shear flow, which is equal to VQ over I. Okay, the second one is the shear stress is VQ over IT, and then to find Q, which is the first moment of area, is equal to A Y bar. Okay, so a piece of warning, this is the one that is going to be difficult. Okay, but I'm going to teach you rules that you have to apply. Okay, so now it's a where it's a mathematical derivation. So we are going to go into the theory of shearing stress. Okay, so if we look at a structure, okay, we look at the cross section. So you have this diagram with you. Okay, so you can get this diagram on Avenue to Learn. Okay, so I want you to look at this cross section. Okay, so this is our y axis, this is our z. Okay, so if you ask me this cross section, so if, for example, this is just an example, if we have a beam, okay, if we have a beam that is simply supported, okay, and simply support, so we have a certain load applied at point P, and the distance from here to here is A, and the distance from here to here is L. Okay, this is our point C. No, I'll call it point D, and point E, and this is our point F. If I were to draw a transformation, this is our X, Y, and this is our rotation Z. So you know where we're looking. So this is like our cross section at, probably we call it NN. Okay, so that is the view of our NN cross section. Okay, so we are going to derive. Okay, we are going to derive. Okay, so by look at this, we are going to derive. Hold on, I just deleted something and I don't know what. Something happened somewhere. Anyway, we're going to derive okay, we're going to derive an expression where the shear in xy, right, is equal to 3/2 Vy over 2BC. No, over over 2BC. Okay, multiply by 1 minus y squared over c squared. Okay, we're going to derive this expression, and as I said, how to derive? Right, how to derive will enable us right to set rules, okay, for the analysis. Okay, so now before we go any further, okay, I want to highlight this. Okay, so if if the shear stress is coming, the shear force is coming in this direction, right? This is our Vy, yes or no, right? So over here, this surface over here, right? This belongs to this surface, this area will intersect the x plane, or will intersect the x-axis, right? So we are going to derive shear xy, right, is equal to shear yx, and this is equal to, now watch this, okay, so this is Vy over Izz, okay, Izz, Qz, right, over T, okay. So we know that Vy is the shear force acting along the y-axis, right? Izz is the second moment of area about the z axis, right? The Qz is the first moment of area about the z-axis, okay? About the what? Z-axis. So about the z-axis, so this, if this is the area of interest, right? The perpendicular distance is what? So this is the perpendicular. The perpendicular distance is our what? Y bar. Yes or no? That's the area. Perpendicular distance, right? To the area is Y bar. So what I'm trying to highlight is you have QZ is equal to A Y bar. Okay. And it's about the first moment of area about the Z. So the Z axis is the reference axis. Okay. So this is the first thing that we have to know. Now, what if now the stress, the shear force is coming about in the Z direction? Okay. So now I'm going to change, right? You guys have seen this, how this is, especially this formula. Okay, especially this formula. Especially this formula over here. Now, this is very different from moment, right? In moment is in fact different because moment, so if it's stress X, this is equal to my. You actually divide by Iyy multiplied by Z. Yes or no? For shear, it's different. Okay. If it's Vy, the axis of interest is 90 degrees to Vy, which is your ZZ, multiplied by QZ divided by T. So if it's over IZZ, you have to multiply the top is in Z. Okay. Now, what if now, okay, I'm going to change this a bit, okay? What if now the forces or the shear force is acting in the X direction? Oh, sorry, Z direction. What will happen? Okay. So now, what if now okay, same thing, right? So what if now the force, hey, come on, the V is in the Z direction. So which axis you have to take? Okay, so now as I mentioned earlier, we know. So if I were to draw a transformation, this is Y, this is Z, right? So if you look at, if I'm going to draw our axis of interest, so now this is our what? Y axis, right? And then the shear now, the intersecting plane is still in the X, but the shear will be in the what? Z, right? So the shear intersecting plane is still the X, right? The intersecting plane of so this area is still the same area of interest. Now the shear force is in the Z direction, and this is equal to the shear stress in ZX. So now this will be equal to what? So watch this. This is VZ over what? I what? YY, right? QY multiplied by T. Now, some of you will say, Eugene, so what is thickness? Okay. So this direction parallel to the YY axis, this is called the thickness. Okay. So over here, same thing. Over here, this direction, this is called our what? Our thickness. Okay. Now, so the next one is Eugene. What is QY? Yes or no? So QY is the first moment of area about the Y axis. Okay. If this is the area of interest, okay. Now the area of interest, if you see how we drew the area of interest, right? It's always drawn furthest away first towards the what? Towards the centroid. Okay, so this is the area of interest. Right? And over here, the dot that I've drawn, that is the centroid of the area of interest. Right? So this distance from here to here, right, will be known as your what? Z bar, right? Because we are measuring along the what? We are measuring along the Z axis. Okay, so when that's the case, QY bar, right, is equal to, right? So this is equal to A. Oh, sorry, what am I? QY. QY is equal to A Z bar. Okay, where this is the area. Okay, likewise over here, right? The area. So this is also our area, the shaded region. Are we clear? Okay, so two different forms of formulas. Okay, so it's all dependent on how or where the